All right, everyone. So today we are going to be learning about some key characteristics of quadratic functions. This PowerPoint is just pretty much pictures of your notes that I'm going to write on. Your notes are going to be linked as a PDF in Kinim, so if you would like to print them out, or you can just take notes based off this PowerPoint, whichever one you would like. So our objective today is that I can graph quadratic functions in standard form, vertex form, and factored form. So the graph of a quadratic function is called a parabola. And we went over that in our last little slide. It was one of the definitions that we covered. So the graph of a quadratic function is a parabola. It looks like a U or an upside down U. And there are three forms of quadratic equations. That first form, that f of x equals ax squared plus b of x plus c, is going to be our standard form. That's the one that we were looking at the other day in class or in your play pause it. The next one that we haven't really looked at it much, but that's f of x equals a times x minus h squared plus k. And this is our vertex form. And then that final one, f of x equals a times x minus p times x minus q, that is our factored form. All right, and so if a is positive, the graph opens up. So it'll look like a U that opens up. And we discussed that a little bit the other day in our PowerPoint as well, whenever we were talking about if we were having maximum or minimums. So, and if our A is then negative, our graph opens down. So it's going to look like that upside down U, which was both of the parabolas that we looked at the other day in class. All right, so just a little bit more of information. So all quadratic equations have a vertex, which is the turning point of the graph. So whenever we were talking about our upside down U's, that maximum was our vertex. Whenever we're talking about right side up U's, that minimum would be our vertex. Quadratic graphs are symmetric across the axis of symmetry, which I may have to write up a little bit. See, and we even talked about this the other day in class 2. We were talking about this, the line of symmetry. Axis of symmetry is the same thing. So, and the axis of symmetry which runs through the vertex. Oh. So, and then the formula to get our vertex, so I'm just going to give you the x values of it. To get your y values, you can plug that x value back in, and your f of x will then equal your y. So whenever we're talking about our standard, which I'm actually going to zoom in, it'll look prettier. So whenever we're talking about that standard form, we're going to look at our x equals negative b divided by 2a. So our b is right here and our a is right there. So we'll have negative b divided by 2a. Whenever we are looking at our, where are we? There we go. All right, whenever we're looking at that vertex form, our x value is actually equal to h, and we kind of got to look at our form here as well. So we have a negative h here, but we're just talking about h. We're not including that negative. So remember, you're just looking at that h value there. And then in our factored form, we're looking at x equals p plus q divided by 2. So that p is right here, and that q is right there. And take note in that form that those are, it's x minus p and x minus q. and we're just wanting P and Q. So remember, if it's a positive, our P would then be negative. And if it's minus P, our P would be positive. All right, so a quadratic function crosses the y-axis at our C value. So for example, back up here looking at the equations again, we have that plus C there. So that is where we are going to cross our y-axis. Sorry, skipping around. The y-intercept always has an x value of 0. For the parabola, the y-intercept will be at the point 0, C. A quadratic function crosses or touches the x-axis at 0. We'll start with 2, actually. Actually, it doesn't matter. We can start at 0. 0, 1, or 2 times. So if we were looking at our nice little graph here, so if our parabola touches 0 times, that means our parabola could be up there. If it touches 1 time, it could come up, bounce off. Pretend that's a U, not a V. And then if it wanted to touch 2 times, we could go up and come back down. So therefore, they would touch twice that x-axis. So we can touch the x-axis either 0 times, 1 times, or 2 times. All right, so we're going to look at this graph and make a few observations. So our vertex, if you remember from earlier, it's our turning point of our graph, so also known as our maximum, and it's going to be our point right there. So, and that point is at positive 1 and 4.5. Our axis of symmetry is going to be on that line, which is that line of x equals 1. And then our y-intercept. So we're talking about our point kind of right there. And that point that is there is at 0, 3.5. So our y-intercept will be 3.5. Then our x-intercepts here are going to be those points. And the points that we're looking at here is that negative 1.25, 0, and 3.25, 0. Negative 1.25 and that 3.25. And if you were struggling by looking at this graph to get any of those, let me know, because I can help you with that, but we've been going over these quite a bit, so I feel like most people are fairly comfortable with these. All right, so graphing in standard form, and then that standard form is listed at the top. It's that f of x equals a x squared plus b of x plus c. And we are going to graph the function that is listed right here. So f of x equals 4x squared minus 8x plus 1. So the first thing that we're going to do is we're going to find our axis of symmetry. And I'm going to zoom in a little bit. And so our b value, here, I can scroll up a little more, is that negative 8 here, which in it is, so we're doing negative, so we're doing negative of negative 8, because we have that negative here and that negative here. That's divided by 2a, which is 2 over 4. So on the top, we're going to have positive 8, and on the bottom, we will again have positive 8 as well, and that'll simplify to 1. So, and to find the rest of our vertex, we're going to plug in that 1 value, because that's what our x is equal to at our vertex, back into the equation. So we'll have f of 1 equals 4 1 squared minus 8 times 1 plus 1, which will give us, so 1 squared is 1, so we'll have 4 minus 8 plus 1. So 4 minus 8 is a negative 4 plus 1. It's going to give us a negative 3. So if we kind of zoom in down here at the spot where it says our vertex, we can go ahead and write in that 1, negative 3. And while we're down here, we could also go ahead and write in our values for A, B, and C. And if you need help, look up here at the original form. So that A value here is going to be 4. Our B value is going to be that negative 8. And our C value is going to be that positive 1. So the parabola here, do we think it's going to open up or down? So we talked about this in class the other day. If we have that positive a value, which we also talk about it up here, so positive a, our graph is going to open up. So if our graph opens up like that, it's going to look like this. So we are going to have a minimum value. Our axis of symmetry is at that x equals 1. And to get our y-intercept, there's several things that we could do. So we could plug in where x equals 0 in that equation, or we can also look back up here. Actually, it was on this page. What is my y-intercept equal to? It's equal to c. So what was my c value here? It was 1. So we'll have 0, 1. And then let's actually graph these first 2 points real fast. So our vertex was at 1, negative 3. And then we had that point at 0, positive 1. So, and remember that axis of symmetry is right there. So we're also going to have a point here at 2, positive 1. And then draw a nice little parabola. Make sure you have arrows on your parabola. That was a problem with a lot of people's homework with the absolute values, that nobody was drawing arrows on the end of their absolute values. And for these parabolas, I do need 3 points. I need your turning point or your maximum or minimum, and then at least 1 point to each side. All right, and then our domain here, so domain is going with our x values, and we have all x values, so we're talking about our all real numbers there. And then our range, so remember we would range from the bottom to the top. So the first point at which we have a y value is there, negative 3, and then it goes on for forever and ever and ever. So we have y is greater than or equal to that negative 3. And then our x-intercepts, you can use Desmos to find those, or you can go on your calculator. If you go on your calculator, I don't have mine sitting here, but I believe if you go to second trace, I believe there's either an x-intercept value on there or something like that. But if you need help finding that, let me know. But so if we were to go to Desmos, we would see that 0.13 is one of our x-intercepts, and 1.87 is our other. So, and you can find that on your calculator. If you need help with that, let me know, or you can always just use Desmos. And whenever you're entering these equations in Desmos, make sure you're using your x values. And with these, you shouldn't have to change your windows too much. All right, so this time I'm going to have y'all complete this problem and go ahead and do it on your own. And then I will have you enter in the values that you got. So for your A value, you should have gotten that negative 1/2. Your B value is positive 2, and your C value is that negative 1. Our parabola is going to open down because we have that negative A value. And because it's opening down, we're going to have a maximum value there. Our axis of symmetry is at 2. And how you were going to determine that was going to be based off that equation right there, is how we're going to get that axis of symmetry. That negative b divided by 2a, which is x equals negative b divided by 2a, which ends up being negative 2 divided by negative 1, which gives us positive 2. And that'll give us our x value of our vertex. We could plug in that x value to get our value for that y there, which would be 1. Our y-intercept is that c value again, so we'll have 0, negative 1. And then if it was me, I would go ahead and graph that vertex. I would go to 2, positive 1, and 0, negative 1. And then I would see that we went down 2, left 2, and I would go down 2, right 2. And that gives us the point of 4, negative 1. And I would draw my lines and my arrows, and I would try to hit the points correctly. There we go. All right, and then here we have the same domain. We're talking about all real numbers again because we have all of our x values going on for forever and ever and ever. Our y values. So again, we're reading from bottom to top. So starting at negative infinity, we have every value all the way until we get to y of 1. So we're talking about between y of 1. So this is going to be when y is less than or equal to 1 because everything below that positive 1. Your x-intercepts, you could have done them on your calculator or in Desmos, and those should have been 0.59 and 3.41. Sorry about that. And those would be your points there. All right, now we are going to look at graphing in that vertex form. And that's how f of x equals a times x minus h squared plus k. The vertex value here is always going to be the value of hk. So, for example, like looking at this number 1 right here. Number 1 right here. So we're looking for hk. And so our vertex here for this number 1 is going to be at 2, 4. And our a value here is also 2. So with this minus inside, just get that number and then use the sign of the outside one, kind of very similar to how we did with the absolute values. And then that 2 is our a out front. All right. For number 2, our vertex is that -3, -5. The reason for that -3 is because the form has that minus there. So our literal h value is -3. And our a value here is that -4. The vertex for number 3 is going to be 1, -2, and our a value is that -1. If this isn't making sense to you, it really kind of stinks because this is just honestly memorizing that the vertex always is there and being able to look at that vertex form to determine that. So now we're going to graph the function f of x equals 2 times x minus 3 squared minus 4. So our a term here is 2. And our a term here is positive. So that means that we are going to... Where's the a term stuff? I guess I saw before. So whenever it's positive, remember we open up. If we open up like that, we are going to have a minimum. Our axis of symmetry here is at the x value of our vertex. So let's go ahead and do our vertex. So our h value here is 3, and our k value here is a -4. So that is going to be x equals 3. Our y-intercept here. So what I would recommend to do, because it's obviously not very easy to find this on this one because we do not have our c value. So I would go into y equals on my calculator, type in 2 parentheses x. If you do not know where the x button is on your calculator, you see the second button that's in the top left corner. Right below it says alpha, and right next to alpha it says xt theta n. That's where you get your x. So then click -3, close that parentheses, hit your x squared button, -4. Now if you want to look at it, you can hit graph. And if you changed your tables the other day in class, hit zoom 6, I believe, and it takes you back to the standard viewing window. And there you go, you see it perfectly. But if we want to get the actual value for that y-intercept, because we don't see it on our screen, you're going to click second graph, which takes us to a table. And I would go until where x equals 0, because that's where our y-intercept is going to be, and it's at 14. And then I would look, so we do have our vertex at 3, -4. You can see that on your table. I would also use the table to get your next values. So I would just go ahead and pick up that 4, -2 that you see. Or if you're doing this on Desmos, you'll just be able to put your mouse over the graph and click on points to determine where they're at. So let's graph this real fast. So 3, -4, 4, -2. So, and then where we have that axis of symmetry here, so we can go up 2 again and left 1 to get our other points. And there you go. Don't forget your arrows and make sure you have at least those 3 points. So For this one, you wouldn't have to graph that y-intercept because you're not even able to see it on the table, but make sure you have 3 points graphed. So our domain here is still going to be those all real numbers. Our range, which is talking about our rise, remember, we from bottom to top. So our y values are starting at -4, and we have everything greater than -4. So we're going to have y is greater than or equal to -4. And then our x-intercepts, so you're going to hit that second trace again on your calculator. And if you hit 0, and then it says left bound, and sometimes you got to click your left and right arrows and go to the left of one of the zeros, right to the one of the zeros, and then guess your 0. And the calculator is telling me that we are at 1.85. So I'm going to round this up to 1.6. And then again, I'm going to hit second trace, and I'm going to hit 0 again. I'm going to go to the left of one of them, to the right of one of them. Guess right about where it's at. And I got that we were at 4.41. So I'm going to round that one to 4.4. And those are our zeros there. And again, on Desmos, you would just put your little mouse on top of the graph and go from there. All right, so this one I'm going to have y'all do on your own and then check your answers. All right, so A here is going to be that, A here is going to be that -1. The parabola is going to open down because of that -A there. The parabola is going to have a maximum because it opens down. Our vertex is going to be at -5, +2, so it'll be at -5. Our y-intercept is going to be at 0, -23. Remember, that's something you're going to have to use the calculator table to find. In our point that we're going to grab, I just grabbed -3, -2. If you're struggling with any of this, please email me so I can help you, okay? Or we can set up a Zoom call. So our first point is that -5, 2. And then we did that -3, -2. So using that axis of symmetry, the other point that we would probably look at would be, so we went 2, 2, would be that -7, -2. Get your points, draw your arrows. Our domain here is still going to continue to be that all real numbers. For this one, we're going to have when y is less than, because we have everything that is less than that +2. But we do include 2 because we have a value there. For our x-intercepts, again, you can use your calculator. -3.60 and -6.40. Should have been something close to what you got there. All right, so now we're going to do one in this last form, and it's that factored form. So that factored form is when A is multiplied by x minus p and then multiplied again by x minus q. So p and q are the roots or the solutions. Those are also what we call our x-intercepts here. So I think I said this in class. I don't remember if I said it on the video last week, but on the ACT, they could ask you for the solutions of an equation. And all they're asking for is the x-intercepts. They could be asking you for the roots. And again, all it is the x-intercepts. It's just a more fancy word. All right, so I'm going to zoom in a little bit more so we can get down here. So remember, we can find our axis of symmetry, which is also the x point of our vertex, by using that p plus q divided by 2. So that's what we're going to do down here. So we're looking at this number 1, f of x equals -3 times x minus 1 times x plus 2. So for that axis of symmetry, we're going to be looking at, and remember, the form, we have those negatives. So we're looking at 1 minus -2. And that minus -2 is going to make it plus 2 divided by 2. All right, and so then that's going to give us 3 divided by 2, and that'll be our x for our axis of symmetry. So it'll be at that line at 3/2. So in our x-intercepts here, what we're looking at is, because remember, the x-intercepts is at that P and at that Q. I think we went over that at the beginning, did we? We did not, but our x-intercepts here are going to be, we have it, P and Q are the roots called the solutions, which are also the x-intercepts. We just waited a little bit to get to it. So we're going to have that 1, 0, and then that negative 2, 0. And that's because of that 1 here, because we have that negative, and then that negative 2 because we have a positive here, and our original form has that negative. All right, let's look at number 2. So when we're looking at number 2 for our axis of symmetry, remember we are looking for that P plus Q divided by 2. So we have negative 3 plus a negative 3 here because we have positives on the inside, so we got to do the opposites, divided by 2. So that'll give us negative 6 divided by 2, which will then end up giving me x equals negative 3. So that's my axis of symmetry there. And my x-intercepts are actually the same here. They're both negative 3, which would be an example of where we bounce off that x-axis. We only hit the x-axis once there. So then finally, this last one, number 3, we're looking at 7 plus negative 1 divided by 2. So we're looking at 6 divided by 2, which gives me that our x value is 3 for our axis of symmetry. And our zeros are going to be 7, 0, negative 1, 0. All right, so now let's look down here at our key features of this f of x equals negative 2 times x minus 3 times x minus 2. So our a value here is that negative 2. So therefore, our parabola is going to open down. The axis of symmetry is, which we'll have to do, where can we do this? We'll do it down here. So we're looking at that 3 plus 2 divided by 2. So that is going to be at 5/2 or 2.5. So remember, that's our x value of our vertex. And so then what I would do is I would type in my calculator negative 2 parentheses 2.5 minus 3, and then another set of parentheses 2.5 minus 2. So I'm plugging in that x value into my x spots in my equation, which then ends up giving us 1/2, so 0.5. So and then I would put this in, I would put it with my x values into my graph and go look at my table. And we would have that our x-intercepts are at 2, 0, 3, 0, which that one you could actually probably look at the graph or the table. You could probably do both. For our y-intercept, we were at 0, negative 12. And just an extra point, we're looking at 4, negative 4, sorry. So we're going to come over here. We're going to go to 2.5 and go down just a half. So we're kind of in the middle of that block right there. Our x-intercepts are 2 and 3. And then I'm going to go ahead and graph that point. 4, negative 4. Oh, and I did that first point wrong. Sorry. You go up, not down. So then we'll go over to 4, and we'll go down to negative 4. And I'll even go down to 1 and go to negative 4, just so we know more of what we're looking at. So if your first 2 points are just kind of right there on top of each other, you can add more to make a more pretty graph if you would like. So the domain is going to stay the same for this one. We're looking at all real numbers because we're going forever to the left and forever to the right. Our range here is when y is less than, because it's all less than 0.5. And our x-intercepts we got from above, so we have 2, 0, and 3, 0. All right. And then this last one here, I'm going to have y'all work it again. If you have questions, let me know. Pretty much just following the same steps as the one before. So go ahead and do that. All right. So we have that our a here is 1. They're probably going to open up because that's a positive number. You should have gotten that your axis of symmetry would be 1.5 because we're doing negative 1 plus 4 divided by 2. That'll give you 3/2. and that's 1.5. So our vertex will then be at 1.5, negative 6.25. Your x-intercept should have been at negative 1, 0, 4, 0. Your y-intercept would be 0, negative 4, and 1, negative 6 is our extra point that we're going to grab. So we'll go and graph it. So we'll go to like 1.5 and go down to negative 6 and put our point just below that line. Probably going to graph my x-intercepts just because that's always easy, and that'll give us a nice pretty picture. All right. Not my best, but all good. So then our domain here is going to continue to be that all real numbers. Range is when y is greater than or equal to that negative 6.25. And our x-intercepts, as we listed above, were negative 1, 0, and 4, 0. All right. Again, if you have any questions, please email me and let me know. I'll be able to go into it in more detail with you. I just figured it'd be kind of helpful to kind of figure out where you're making your mistakes. So, homework. It is linked as a PDF in Kitum. This needs to be submitted into Seesaw under the Key Characteristics of Quadratic Functions homework activity. It is on a PDF document, and you can print it out and write your answers on there, or you can write your answers on a blank sheet of paper. Just make sure that you get it turned into Kitum under that specific assignment. I have all of your grades updated in Skyward. So if you have any questions about anything, email me. I sent out an email yesterday, actually with some test dates on it, and I forgot about the 15th and the 22nd, y'all not being here. So the A-Day test dates are still the same, but the B-Day test dates are, give me a second, and I'll look it up. The B-Day test is going to be on the 23rd. So A-Day test is going to be on September 17th, and the B-Day test is going to be on September 23rd. All right, if y'all got any questions, email me. I can set up a Zoom call with you, or we can try to figure it out over Remind, but just let me know.